Hi folks, today we're going to do projectile motion problems where the projectile lands on a slope. The first problem is this, where the incline makes an angle of 30 degrees with the horizontal and an object is projected at an angle of 30 degrees with the incline. That means 60 degrees with the horizontal. And this projectile is going to go and land somewhere on this slope. And the question is, what is the time of flight? So, as always, we'll set up our coordinate system like so. I'll take my x-axis horizontal and y-axis pointing upwards vertical. And then we will separate motion in the x and y directions as always. So, in the x direction, y direction. Now, the projectile's initial velocity is 40 meters per second, let us say. So, its horizontal component, that is in the x direction, is 40 cos 60. So, ux cos 60 is half, is 20 meters per second. And uy is 40 sin 60, that is equal to 20 root 3 meters per second. Sin 60 is root 3 by 2. And acceleration in the y direction is minus 9.8. We're going to take it as minus 10. Minus because we have taken y-axis pointing upwards and gravity acts downwards. So minus 10 meters per second squared. This is meters per second. And acceleration in the x direction is 0 because the downward force of gravity has no horizontal component. Now, the secret to solving any physics problem is to make drawings. So, we first drop the perpendicular here so that from this drawing it becomes clear that this is the displacement in the y direction. Keep in mind, displacement in the y direction is by definition change in the y coordinate. It doesn't matter that it goes up and comes down. This is the change in the y coordinate. And from here to here is the displacement in the x direction. That is the change in the x coordinate. So, once we make a drawing, you can see immediately a relationship that jumps out from the drawing. The relationship is Sy by Sx is tan 30 degrees, which is 1 by root 3. Now Sy is a positive number, so it's the length of the opposite side for 30 degrees, and Sx here is also a positive number, so it's the adjacent side for the 30 degrees. So let's write down Sy and Sx. So Sy, S is equal to ut, 20 root 3t, plus half at squared minus 5t squared. And Sx is equal to ut plus half at squared, a is 0. So this relationship becomes 20 root 3 t minus 5t squared divided by 20t is equal to 1 by root 3. So all we have to do now is solve for t. And this equation gives us the time of travel as 8 by root 3 seconds. Supposing I'd asked you how far up the incline does it fall. That's very easy. You can take this time of travel, substitute into Sx, substitute into Sy, and use Pythagoras theorem to find the distance along the hypotenuse. Let's go to the next problem where the incline is downwards. In this problem, the incline now makes an angle of 30 degrees from the horizontal, but it's a downward slope. And once again, we are projecting an object, let us say at an angle of 30 degrees to the horizontal, and let's say with an initial velocity of 40 meters per second. The question is, what is the time of flight? So we should expect the parabolic path to look something like that. So as before, we drop a perpendicular to the horizontal line so that from the drawing we can tell that this is sy. As you can see, it's the change in the y coordinate, and in this case sy is negative. And along the dotted line up to this point, it is sx, change in the x coordinate. That is from point A to point B is sx, B to C is sy. Now, as always, we'll set up our x-axis this way. I'm going to continue to take my y-axis pointing upwards, and we will separate the motion into x and y directions like so. X, y. Now, ux is 40 cos 30 because the x-axis is horizontal. Cos 30 is root 3 by 2, so that is 20 root 3 meters per second. And uy is 40 sin 30. Sin 30 is half, so that is 20 meters per second. Ay is minus 10 meters per second squared. Ax is 0. And let's write down the expressions for sx and sy. Sy is equal to ut plus half a t squared. And sx is equal to ux t. Now it is tempting to write by looking at this triangle that sy by sx is equal to tan 30 degrees. But stop. Tan 30 degrees is the length of the opposite side divided by the length of the adjacent side. Remember, sy in this problem is negative. So the length of the opposite side is minus sy. The adjacent side sx is already positive, so we can leave it as it is. So this is our relationship. So minus sy is 5t squared minus 20t divided by sx, 20 root 3t is equal to 1 by root 3. So we can solve this for time. T is equal to 8 seconds. And as before, we can take this 8 seconds and plug it into sy and sx, and we can take sy squared plus sx squared to get the distance along the incline if we had asked for that. Our third problem is this. An object is projected at 40 meters per second at an angle of 30 degrees to the horizontal, and a distance of 40 meters from the point of projection, the ground slopes away at an angle of 30 degrees. So, this angle is 30 degrees. The question is, what is the time of flight of the projectile? Let's assume that the projectile clears the horizontal part of the ground and ends up landing somewhere on the slope. So, as always, first step in all physics problems is the drawing. So, let me draw this horizontal line representing the continuation of the flat part of the ground, and let me drop a perpendicular here so that you can see now that A to B is the horizontal displacement, change in the x coordinate, so that is sx. B to C is the change in the y coordinate, that is sy, and sy is negative. Once you make this drawing, the equation jumps out at you. Look at this triangle. Sy is negative, so minus sy is the length of the opposite side for 30 degrees divided by the adjacent side. Let me call this point D. The adjacent side is dB, which is AB minus AD. What is AB? Sx minus 40. This is tan 30, 1 by root 3. So once again you can see the power of making a drawing for every physics problem. The equations jump out at you once you make a careful construction. So, as always, x-axis to the right, y-axis pointing up, and let's separate x and y. x, y. ux, x component of the initial velocity is 40 cos 30, that is 20 root 3 meters per second. Uy is 40 sine 30, that is 20 meters per second. Acceleration in the y direction is minus 10 meters per second squared. Acceleration in the x direction is 0. So we can write down Sy is equal to ut plus half a t squared. And Sx is uxt. Ax is 0. So let's substitute this into this equation. Minus Sy is 5t squared minus 20t divided by Sx 20 root 3t minus 40 is equal to 1 by root 3. So let's solve this quadratic equation. The quadratic equation gives us two values for t. T is equal to 0.625 seconds and 7.375 seconds. Both positive values. So which is the correct one? And why are there two solutions? If you think hard about this, I will leave it to you to think about it. You can easily figure out, for example, how long it takes for it to land at this point if the ground were level. Let's call that point E. So the time taken to go to AE, you can calculate it. From that, you can figure out that the correct answer is 7.375 seconds. But what about this one? Where did this come from? If you think about it, you will realize that if I multiply top and bottom by minus, that is, if I take Sy by 40 minus Sx is equal to 1 by root 3, it's the same equation. So now this equation can be interpreted as follows. Supposing I continue this slope upward like that, it intersects the projectile motion at this point. Let me drop a vertical. Now you can see that this is also 30 degrees. This is Sy for this point, and the adjacent side here is 40 minus Sx. So this equation is satisfied for this point. That will correspond to 0.625 seconds. Now, I don't expect you to have figured this out right away. When I got this answer, I was wondering why there are two positive answers, and it took me a little while to figure this out. But you can see now the correct answer is 7.375 seconds. So I'm going to stop the video here. Until the next video. Bye-bye.